velocity of a river will be different at different depths and along different reaches. To measure the velocity, a timed experiment can be conducted. Measure a 10-metre stretch and use a stopwatch to record how long a float takes to travel the 10-metre distance. Release the float from rest, as pushing or throwing the float will reduce the degree of confidence in the result and will be a limiting factor. Do the experiment 3 times so that you can work out an average velocity. Once the velocity of water has been determined, one can introduce the concept of friction and the effect that this has in respect to erosion and deposition. To measure the width of a river, run a tape measure across the river at 90 degrees to the direction of flow and about 20 centimetres above the water so that the tape does not catch on the flowing water and can be pulled taut. The start and finish points are where the dry bank meets the water. Observations from directly above the tape to record the distance will ensure that the margin of error is kept to a minimum and a good degree of confidence is maintained. The next step is to record the depth of the river at regular intervals. Decide and record what intervals to use depending on the width of the river, the time available, and the level of detail required. A metre rule can be immersed until it reaches the riverbed at each interval and the depth of water recorded. A tip here, to ensure that there is a low margin of error, is to angle the ruler at 90 degrees so that it has a low profile in relation to the direction of water flow. To measure the gradient of the river, we use a device called a clinometer to measure the angle between 2 ranging poles. Measure a distance between 5 and 15 metres, remembering to record the distance used. Place the ranging poles on the riverbed. Ensure that the pole is vertical, as this will affect the accuracy of the recording. At the downstream pole, use the clinometer to record the angle from a fixed height to the corresponding fixed height on the upstream ranging pole. Now record the value. Once one knows the distance and the angle, it is possible to work out the gradient and to plot this. How to plot a cross-section of the river. We have already recorded some of the measurements needed to do this. The width of the river and the depth of water at predetermined intervals. So we can plot a cross-section of the river, measure the distance between the top of both banks and record this. On each bank in turn, measure the horizontal distance between the top of the bank and a vertical ranging pole placed at the water's edge. Then measure the distance between the water's edge and a level that is horizontal to the top of the bank. This could be done visually, or for a more accurate reading, use a spirit level or a clinometer, which can measure angles, as this will help to ensure that a level recording is obtained and a good degree of confidence is achieved. Once one has determined and recorded the height of both banks and the horizontal distances between the edge of the water and the top of the banks, then it is possible to work out all of the gradients and for students to take their measurements and be able to plot a cross-section of the river. If you choose to plot a cross-section on a meander, then the gradient of the banks and the shape of the riverbed should reflect the process of erosion and deposition. Studying aquatic invertebrates can tell us a lot about the health of a river and can help us deduce if it's polluted and also the chemical composition of the water. Equipment needed to carry out invertebrate studies includes a dipping net, sample tray, identification and recording sheets. By carrying out a series of kick and sweep samples, it is possible to complete a biotic index that measures the biological quality of the rivers using invertebrates as indicators of health. The field observations and experiments can be used to draw a cross-section of the river and to discuss the effect that shape, profile, depth and gradient of the river has on water velocity, and the effect that this has in respect to erosion and deposition. How might the width and the gradient of the river change from the source to the mouth? What differences in water velocity or gradient of the banks might we expect to see? These factors and the invertebrate observations can be useful and help us to understand the relationship between the physical and biological properties of the river, the effects that oxygen levels, pH, nutrient levels and pollution might have on aquatic wildlife, the natural environment and ultimately human resources.